Now it's time to learn what a pointer is, how to declare it, how to assign an address to it, and what the dereferencing or the indirection operator means and how to use it. Right. So a pointer is a variable that holds the location of, literally the address of, a variable stored in computer memory. Right. We're going to declare pointers with a data type. We're going to use the asterisk right before the variable name to indicate this is a pointer, and we're going to make a pointer point to something. We're going to assign the address of a variable to it, right? So any number that we store in a pointer is always treated as an address. We want to remember that pointers always point to memory locations. So we'll create pointer variables. We'll make them point to memory locations, right? There are several pointer applications in C programming. One is to pass information back and forth between a function and its reference point. We can return multiple data items from a function via function arguments, right? So we'll make function arguments that are pointers and allow us to treat them as both input and output, right? It'll provide an alternate way for us to access individual elements of an array. We'll be able to pass arrays and strings as function arguments. It also enables us to have references to functions, so we can have pointers to functions. We can actually list a pointer to a function in a parameter and pass that pointer to another function. Right? That's a little bit beyond the scope of our class, an advanced technique, but after you learn pointers, you'll be able to master that as well. And then we can create complex data structures such as trees, linked lists, stacks, queues, and graphs. These data structures have very specific uses. They're more efficient for certain applications, right? And we need pointers to be able to create those, right? And also dynamic memory allocation of a variable, which is a few chapters away. We'll learn how to do that, right? So let's take a look at the C pointer syntax, right? Whenever we declare a pointer, right, we're always going, just like any other variable declaration, it's going to have a data type and it's going to have a name, but we're going to put the asterisk in front of it to indicate that it's a pointer, right? So if I want to declare a pointer to an integer, right, a pointer to an integer data type, then I write the data type here. I can put the asterisk right after the name of the data type, and then I can put the name of the variable. That's one method. Or the other method is I can say the data type and I can put the asterisk right in front of the variable name. Right? My preferred method is to put the asterisk right in front of the name. So that's just usually the way I write it. It's easier for me to remember this syntax than that. But either one is legal. Right? So either one of these, if I wanted to declare a pointer to a double, right? So these were integer examples. Data type is double. I can put the asterisk there and then put the name. And this variable, PTR3, is a pointer to a double. Or I could declare it like this, data type, and then put the asterisk immediately in front of the name, right? So either way that makes sense to you, you'll write it like that. All right. That's how we declare a pointer, right? Once we declare it, it has garbage in it. Let's just go ahead and pop up a C program. All right, we know if we declare a variable x, if I wanted to try and print out what was inside of x, right, %d, x, I would expect this to have garbage in it, right? So, all right, so I can see that x just has some variable of 56 in my system, right? If I go ahead and execute this line with a next line here, right, this pops up, I printed out 56, right? But I didn't know what was going to be an x because I hadn't initialized it to anything, right? Similarly, if I declare a pointer, so I'm going to declare a pointer to an integer data type, so declare a pointer to an integer data type. Right? So the data type is int. Right? I'm going to say this, I'm going to say px. Now, you can give these any names, right? These follow the C identifier naming rules. A lot of times I'll put a p in there to indicate in my name that that's a pointer to something. But once I declare it, I don't know what's stored in it. Right. Once again, if we do a run to cursor here, Right. Oh, darn it. So the compiler optimized this out because I wasn't using it. Let me just stop this. All right. Let's go ahead and print out, right, data stored in X. Right, and let's print out what's stored in the pointer. Right, data, new line, data stored in PX. All right. I'm going to use %p to print out what's stored in the pointer. Mine is PX. It should be just some sort of garbage address because I haven't initialized it to anything. All right, so X had the 56, PX has a hex 8, right? That's probably not a legal address within my program's memory space. But yeah, if I were to just go ahead and say, debug, right, next line, and then next line, all right, we can see here that we got this value of 8 popping up. Now, remember this point, prints this in hexadecimal for me, so it showed quite a few hex places. Remember that each hex place, each hex digit represents 4 bits of memory. All right, that's just to show though that we had garbage in here, right? So I don't want to use a pointer normally without making it point to something. And how do I make a pointer point to something? Right. Well, I do that by assigning it to an address. So here's a couple other examples I should mention. Right. Every pointer variable has to have this asterisk in front of it. Right. So here, excuse me. Here I'm declaring P is a pointer to an integer data type. FP is a pointer to a floating point data type. This is correct, right? Here's PX is a pointer to an integer data type. I've got the asterisk right here. But now if I say int, there's a space here, right? Asterisk PX comma X. PX is a pointer to an integer data type, but X is just a regular old integer, right? An ordinary integer variable. Right? If I want to make something a pointer, I have to put that asterisk right in front of the name. Right? One asterisk here doesn't mean that everything on the line is a pointer. It only means that PX is a pointer. X is just an ordinary int. PX is a pointer to an int. Right? So multiple pointers. Here's the correct way to do it. Declare the data type, then put the asterisk right in front of the name. Separate the variable names with commas. You don't have to leave this space in here. I did that for readability. Right. This is incorrect if you mean for all 3 of these. So if you wanted all 3 of these to be pointers, if you just say int star, so we often say star instead of asterisk, int star, the first variable ptrx will be a pointer to an int, but ptry and ptrz will just be ordinary integers, right? Integer variables. They won't be pointers. But remember, if you're going to do multiples per line, put that asterisk right in front of them, and that's why I choose to, is my personal style, go ahead and always put an asterisk right next to the variable name. It's more clear to me which one is the pointer. Right. So here's an example here where I've declared P as a pointer to an integer data type, and then we use the address operator to assign an address of a variable to a pointer. A pointer always has to point to some address, some variable, right? And we want to use integer pointers to point to integer data types. We want to use character pointers to point to character data types. Floating point pointers to point to floating point data types. Right. So let's see how we do that in our C program now. Right. So here I want to make PX point to X. In order to do that, then I assign to PX the X's address, right? Assign X's address to the pointer variable PX. All right, now, in order to see what's stored inside of px, let's go ahead and print out x's address. So let's go ahead and let's just assign some value to x. Right. And when I declared this, I could have initialized this here. Right here, I could have said, make this point to x. That's legal. Let's just do that here in the separate step. All right, so now as we run through the debugger, we'll see that x has a known value of 10. Px will have the address of x. Let's just go ahead and print out then, right, x's address. So printf, right, x's address is, all right, let's just go ahead and use a %p for that as well. And now to print out the address of x, I have to use the address operator with x, right? And then we'll print out what's stored in px. And some white space at the end of that would have been nice. We can see the data stored in x is 10. X's address is 0028FF08. And the data that we stored in px is 0028FF08, right? X's address. So let's go ahead and put a little, all right. It's a little neater so we can see the two line up, right? So we've got 10 and x, x's address happens to be this, and then now px is pointing to x. All right. Now, why would we want to make this happen? Right? This is a lot more, this seems like a lot of extra work, but it will pay off when we start working with functions. Right? So in this case now, that we have px pointing to x, can I make px change the memory contents of x, or can I make px read the value of x? All right. So we're going to use the indirection operator. And sometimes it's referred to as the dereference operator. Right. So use the indirection of the dereference operator to read the value. Stored in x. Right. So when we write indirection operator, so star px, this is an alias for x. All right, so here we go. We're going to value returned by dereference px is, all right, when we use the indirection operator to read what's stored in x, remember x's data type is an int. So here I should use %d to print this out. And so I'm going to dereference px, right? This says right here, px points to x. This says go to where px points and return the value, right? It's an indirect way of addressing x, right? It's the very same thing as if here we're going to print out the data stored in x. So let's just go ahead and move this down here. We'll see that these are the same value. All right, so x's address and the data stored in px, we see those two are still the same. Oh, I forgot. I didn't put a new line here. That's ugly. Hard for you to read. So there's X's address, the data stored in PX, right, is X's address. But now, right, data stored in X, well, we just go ahead and reference that with X, right, and we see the value of 10 coming up. Right, when we use the indirection operator, so the indirection operator is put after we declare this is a pointer. Whenever we use the asterisk with this says go to where this variable points, go to that address, and return the value stored at that memory location, which in this case is 10, right? Because P points to X, right? Now, this is the point where you're probably saying, why would I go to all this trouble? Because I can already create X, right? And I can assign a value to it. Why would I go to all this extra trouble? Normally, we wouldn't do something like this. This is so you can learn the pointer operations. This comes in handy for all those other uses on that slide. So we have to learn all the syntax of using pointers before we can start using these in functions and start using these with other data structures. Right. And all right. And so here, this is what we mean by the indirection operator, the asterisk. So when we use the asterisk here with the data type, we use it to declare a variable as a pointer. When we actually use it with a physical pointer variable itself, it says go to the memory location where you point and return the value stored there. So in this example, we declared a pointer to an integer data type. We assign the address to some variable z. Z should be an int, right? Like type should point to like types. And now if we say star P, that says go to Z's memory and return what's stored in Z's memory, right? So it's an alias. This is an alias for the name Z, right? It's an alias for whatever this points to, right? Now let's go ahead and see how we could use pointers with scanf, right? We've already then actually, yeah, let's do this. And I'll go back and show you how to rewrite what's in X's memory. All right, so we can use then, we've used the address operator with scanf. All right, we can actually now use a pointer then to store something in a variable. All right, so let's think of then how we would do that. So let's make another example. A new C file. I'll call this pointer scanf. And I'm going to remove this one from the project. All right, here's our new one. All right, we're going to use scanf, so we're going to need the standard input-output library. Create a create a variable of type int. So here's our int x again. It's not initialized. We're going to use scanf to read a value from standard input, from the standard input stream, which is a keyboard, and store it in X. Right, so we already know how to do that, right? X is an int, so our specifier is %d. We give this the address of X, and so I'm doing a run to cursor. It's waiting for me to type something in. I'll type in 99, hit the enter key, we can see X gets 99. Right, that wasn't real user-friendly in terms of telling the user what to enter. Right, but we get the idea then that scanf reads this in and stores it in X. Right, that's how we can do that. So we're going to create a pointer to an integer data type. All right, int star px. And I'm going to point px to x. All right. To do that, I assign to px x's address. All right. And I still want to use scanf to read a value from the standard input stream and store it in x. But I'm going to use then px to do that. And px, okay, so px saying px is the same as saying address of x, right? Because we assign the address of x to px. All right, so let's compile. Let's make sure the compiler's happy. All right, compiler didn't complain. All right, just again, a run to cursor. All right, so x has that old value of 99 from last time. Just want to type something different. Let me type 75 here. Notice now x has 75 in it. Px stores the address of x, but so we use px in this case, right, because scanf requires an address of x. Saying px is an alias for saying address of x. It's the same thing. Right. All right, and that's how we can use that with scanf. Let's go back to this dereferencing concept. So I'm going to open back up this other file I just created called practice. Let's go back here. All right, so this is the file we were just working with. Remember, we went ahead and stored some information, or we read the information stored in X here with the indirection operator. So let's store a value in X using px. All right, so if you want to write something to X, we can simply assign to px. All right, so we initialize x to 10. All right, let's store some other number like 42. When we do that here, this says take this expression, 42, and store it where px is pointing. Remember, dereference px, so star px in this context means go to where px is pointing, go to that memory, and assign this value. So we're actually using the indirection operator to write. Here we use the indirection operator. We said we reference that area. We were just reading it, right, and displaying it. Here then, right, we're going to store a number and we're going to override that. So if we, oops, let's see. I need to add that into my project. I need to remove the previous example. Let's put this one in our active project. Let's build it. All right, now run to cursor. All right. So run to cursor is waiting to execute this line, right? We stored 10 inside X. PX is pointing to X, right? It printed out this information. It ran through these printouts. This is what we've done before. But now we're going to overwrite what's in X. So now if I say, right, in this case, if I say next line, now we can see that X has the value of 42 stored in it. So here's an example then where we're using this to overwrite where PX is pointing. Here's an example where we're using to read. Here's a read operation. We simply use the indirection operator to go there and say return what's stored there. Here, because the assignment operator has the side effect of writing something in memory, We're doing this to write something in X's memory. Let's see. Oh, I'm going to try another example. All right. So let's write another, we'll write some example programs. Let me just pop this up. Let's go over a summary of what we've learned about pointers so far. So we declare a pointer variable with a data type and we precede it with a star when we declare it. Right? That when I said int star px, then px was a pointer to an integer data type. Remember, whatever we store inside a pointer variable is always treated as an address, right? As an address location. So we always want to store the address of something else in there, right? The address operators used to store a memory address, right? We've done that, and then we use the indirection operator to either read or write. The indirection operator was an alias for that variable name, right? So we've seen examples of that with int. Right, let's go ahead, and in the next lecture, we're going to write some different pointer examples. Right, this is just the end of our pointer.